So let's do this example problem. 2.7, it says a jet lands on an aircraft carrier at 63 meters per second. A, what is its acceleration if it stops in 2 seconds due to an arresting cable that snags the airplane and brings it to a stop? And B, if the plane touches down at position x initial equals 0, what is the final position of the plane? And so I got it ready ahead of time. Here's how I would set this up. Here we have a beautifully drawn aircraft carrier. Okay, and here's our jet just touching down. And we're going to say that this position is 0 and its initial velocity is 63 meters per second. And then an arresting hook brings it to a stop. Now I drew it over here. It actually would probably be over here somewhere. But anyway, in 2 seconds, your velocity is now 0. Now look for that when you're doing a problem. It says it brings it to a stop. They're not saying the final velocity is 0. You have to understand that. You have to read the problem and say, okay, that means that my final velocity is 0. Okay, so in part A, we want to know what is the acceleration, and part B, what is the final position. So let's solve it. Now I would use the kinematic equations for this, and I would look at what I'm given. Let's do part A. We want the acceleration. What do we know? We know the initial velocity, we know the final velocity, and we know the time. And we're looking for acceleration. So I would look at that list of 4 equations, and I said, what has those 4 things? Well, what are we missing? What do we not have that we don't need? Well, we're not given delta x. We don't know what delta x is, and we're not looking for it, not yet. So I would say, what doesn't have delta x? What is no delta x? Look on your list, it's the first one. So for part A, I would say, okay, v equals v naught plus at. That's the first equation. And then we simply solve for a. A equals v minus v naught over t. And look, this is just delta v over delta t. That's how we define acceleration, right? V final minus v initial, that's delta v. And the final time, well, it's like t final minus t initial. It's kind of like delta t. Because t sub 0 is 0. Anyway, so the final velocity is 0 minus 63 meters per second divided by time, 2 seconds. And when you plug that in, you get negative, what is it? 31.5. I think the book rounds it to 31. It doesn't really matter, but meters. Now, you can put meters per second every second. I like this. This is what acceleration is. It's a change in how fast you're going in meters per second for every second. So we're shedding 31.5 meters per second of velocity every second. Now, or you can write it as negative 31.5 meters per second squared. I don't really know what a square second is, but mathematically it's equivalent to this, and it's easier to write down. So this is our answer to A, to part A. Now part B, we want x final. Well, we know that delta x equals x final minus x initial. And what are we given? Well, we're given the initial velocity, the final velocity, time, and we want delta x. What are we not given? We're not given the acceleration. So I would use the kinematic equation that doesn't have acceleration in it, which is the second one, right? So you can say delta x equals v final minus v initial. I don't need to, sometimes I get the subs, plus v initial, I'm sorry, divided by 2 times time. So v final is 0. V initial was 63 meters per second divided by 2 times time times 2 seconds. And so that's going to be, that's going to be 63 meters. Now, is that x final? Well, what's x initial equal to? It's equal to 0. So therefore, x final, am I on screen? Yes. So x final is just going to be 63 meters. Okay. So this is a very easy problem, actually, I think, once you know what to do. And I want you to develop really good problem-solving technique in this class. That's really as important as learning, the specific physics equations and concepts and whatever. And this is what I like to like. What do I know? And I like to draw pictures of what I know. Okay, now if you don't have these mad cartooning skills like I have, look at that. It's like a work of art. If anybody wants this, I can give it to you. I'll sign it. Okay, and you can put it on your fridge. I want you to visualize what's happening. And then you write down what's given in terms of the variables that we use. And then you apply the basic equations. And the 4 kinematic equations that we just developed, I consider those basic equations. Like, that's where you start. And then you use those basic equations to solve your... And notice that throughout, I'm showing my work, I'm including units, I'm boxing my answer. It's very clear. So when I look at your work like this, I can follow it. You can follow it. Okay. So this is kind of what I'd like to see. Some of you will do a better job than I can do with the drawings or making it nice and neat, but which is great. And I don't grade based on handwriting, by the way, unless it's so atrocious I can't read it. But yeah, sorry, Maverick. I don't know why you took this class, but just kidding.
Trying to fix the robot.
But anyway, that's how it's done. Anyway, enough. Any questions? Okay. That is all.